Hi, I'm Duana. I'm going to talk about microservices at Soundcloud. I'm working in Berlin at the moment with Soundcloud. I've been with them for almost 4 years. I used to work in corporates, and I actually know Yoshi from uni, so I was just passing through on holidays and I can speak. So this is my office in Berlin. It's on the former Berlin Wall. Office tree and a building with a picture of the famous picture of a soldier kind of jumping over the wall. So we have lots of tourists on the way to work. It's quite fun. And this is inside the office. So the office has become a bit of a tourist destination itself in Berlin. It was like a converted factory. We've got all sorts of amazing rooms, like a fireplace for the non-Berliners, because Berlin has 5 months winter. A sleep room, playroom, etc. A maker's room, and I get paid in fresh, unlimited avocados, pretty much. Just to set some expectations, to avoid disappointment, please lower your expectations. I'm just passing through, and this is just a brain dump of what I've kind of witnessed building microservices. It's a 4-year journey that we've been on. So not super prepared, but I have enough content from just having done this for a while that I think we'll have some interesting conversations. I should have maybe checked that with Yoshi first. No one paid for this, did they? Right. So I guess again, setting the scope at SoundCloud, I've been on feature teams, like maybe on the periphery, or a consumer of the microservices architecture, so I've been building microservices, but I haven't been on the infrastructure teams kind of setting up the infrastructure, but I've been a keen observer and a user. So I might not know all the details, but I'm going to paint like the general picture of how it is there. So SoundCloud, if you haven't heard of it, is a music and audio platform for creators. They can upload, build a community, connect with them, gaming audience, and we have 12 hours of audio uploaded every minute. And as a listener, you can obviously discover unique content. You can go on these, I liken it to, on Wikipedia, you go on a Wikipedia rabbit hole. On SoundCloud, you can go on a SoundCloud rabbit hole. You listen to one track and you end up somewhere completely different at 3 a.m. in the morning. And we have 175 monthly active users. So the story of how SoundCloud moved from a monolith Rails architecture to a microservices architecture is well documented. I'll give you references later. As I said, it's been a 4-year process. As I started there, they were just starting to realize that the Rails app was not scaling. We had at that time maybe about 50 developers. So trying to get, like 30 back-end developers and 20 front-end developers trying to make changes in this one huge code base was really causing a lot of pain. And at the time, we considered, which way do we go? Do we go let's invest in the monolith, let's invest in the techniques to get lots of developers to work on in parallel, like Facebook, or do we go down the microservices route and invest in all the infrastructure to quickly create lots of independent small services, which is the way that Twitter and Netflix were going. And we took the bet on Twitter. And so there was Twitter and Netflix. Netflix was going, I think, their own stuff was Closure, and Twitter was Scala or Finagle. So we thought that the Scala Finagle abstractions were more intuitive, and just took a bet on that. So, okay, this was the monolith, just basically the monolith was the Rails app, which had all of the data models. Originally it was serving HTML with Rails ERBs. And we then had a public API fairly early on, so that third-party developers could do cool stuff with our content. And we also used our public API for our own clients so that we could, through dog fooding, ensure a high quality, current maintained API. And our clients were our mobile clients, iPhone, iOS, Android, and a big one-page JavaScript app, which was our version 2 of our website. And we also have an embedded JavaScript player, which I think is one of the great things SoundCloud's done for the web, because anybody can really easily embed an audio track in their blog or website. So all of these were our clients, and they were all using the one Rails public API. And the talk that I gave at Yale Connected last year was actually talking about how we use the concept of microservices to break up the public API to make client-specific APIs, because the public API was a development bottleneck itself, because we had like a team of public API developers who would have to service all of the feature requests of all the different clients, and the different clients have really different needs and different characteristics. So web has a lot of real estate, huge data pipeline, and mobile is the opposite. So what we moved to, and we're, I'm guessing 70% of the way there, is, so yes, we're breaking up the public API into these client-specific or presentation-based APIs, so that the API mobile can get exactly the endpoints and representation they want. The web can have their own representations, and same for the mobile web. And these presentation or aggregate APIs themselves are getting data from underlying microservices, which are like the data-oriented microservices, so the underlying kind of data model. And each of these underlying microservices, so yeah, we've converged to using Scala and Finagle, but that wasn't our first choice. I mean, that wasn't our first decision to like make everything Scala. We thought, we weren't sure, so we thought let's do a few experiments. So we had a bit of Clojure in there. We had and still have some Rails and some JRuby. But we thought, we even had Node.js, so I did learn Node.js by building a microservice and maintaining one on that. But over time, we realized that when you're going down the microservices route, there's a lot of shared infrastructure, and there's a lot of knowledge that you have to build up in the stack. So, of course, if you've got all these different stacks, it's going to be hard to move developers between teams. So we originally thought, well, let's restrict it just to JVM-based languages. We were really keen not to restrict people, because people are really teams. We wanted to allow teams to still be autonomous and choose the tools that they thought were best for their domain and in their expertise. So we restricted to JVM. That's why we had some JRuby instead of Rails. And now we're converging more and more to Scala, because we've realized that even though we can still leverage a lot of sharing on the JVM bytecode level, there's still a lot of knowledge in understanding the HTTP stack in each language, and building shared libraries for all of that. And even learning the language itself, to have someone, to learn Scala is a high investment, and then to have to go on Clojure, or become proficient and an expert in more than just Java, that'll take time in terms of ramping up. So that's the broad architectural level. On the organizational level, we used to have a fairly horizontal split of front-end, back-end infrastructure. And the first kind of partitioning we went to was get the clients to build their own APIs, these aggregate representation-based APIs. And we thought we would try to make it easy for them, try to make API development for them a bit like scripting, so provide a framework and provide lots of client libraries and examples that they could just build, string building blocks together and make their APIs. So the mobile team started to they got a couple of back-end developers and they started to build their own APIs. And then we had these teams that were specialized around the back-end services, and the back-end services were partitioned per domain area. So there was, for example, a team called Social Graph, which was responsible for users and the social interactions between users. I was on the payments team, so I created and maintained the payments API, which we pulled out of the Rails mothership. Mothership is our word for monolith. I'm just curious, I'm going to use you a little bit. Who has a monolith or had a monolith? Okay, what did you call it? Sorry? Sorry?
Thing.
Thing? Okay. Okay. Any others? I've heard a rhinoceros, Death Star. Sorry? Big ball of mud, yeah. A BBM maybe, just shorten that. So mothership, even we shortened mothership to Moshi. And then we had to, so in breaking up the mothership, so it was just Rails with all of the active record, everything on there. And as we were pulling stuff out, like the payment service, for example, we pulled it out whenever a subscription was purchased, we would still have to update the user. So we had to build an internal API to our mothership, and we called that API Moshi Moshi, like hello mothership. And Moshi Moshi is still there, alongside a lot of other strangely named services. So once you, the culture of getting into Soundcloud is understanding the stories behind all these funny names. So yeah, the teams, we had these specialized teams around domain, the payments team. The payments team was already a little bit feature team based in that we had a front end developer who would do the work in the Rails front end, or the web front end. But then we realized, we still have these big mobile team that's not feature based with back end developers, so they still relied a lot on back end developers. And we moved recently to a more pure feature team approach, where you have mobile, backend, and other web capabilities within the one team, and designer, of course, and product manager. And that comes with a whole host of challenges. We can talk a bit more about that. But with these mobile web and mobile web specific APIs, what we would find in a feature team, say I wanted to update something in the comments, I'm in the team that deals with comments and messaging. If I had to change something, I'd have to change all of the front-end clients and then all of their specific presentation APIs, as well as in the comments underlying microservice. So that's a little bit of a challenge. We're still dealing with, when you've got these microservices in the underlying layers, they work really nice, they're really small and really independent, but we have these big monolithic mobile applications where it's not clear how in feature teams the mobile developers can work well together to add their feature changes but also stay across cross-cutting concerns. So to stay across cross-cutting concerns and to deal with cross-cutting concerns, we have, alongside the vertical feature teams, horizontal core teams. So for example, to allow, like I said, these front-end teams to build their own APIs without being back-end developers, to build a framework to help them, we had a core library team, and they would just be dedicated to making these other developers efficient. We had a core web team, core mobile teams, and they were really looking at how do we keep those big shared pieces of infrastructure current, maintainable, effective for developers to use and get up to speed on some common things. I'll show a bunch of examples in a sec. So this common framework for the presentation APIs, we called it BFF. Can anybody guess what that stands for? Best friends forever! Yes, you win the prize. You can't see. Oh, you can now, yes. The sun went down. So you should start like after sunset. It's like a cookie and a glass of milk holding hands. And it wasn't like that originally. Originally, like that was the name and the logo. So it stands for actually not best friends forever, but back end for front end. And it's become a pattern now. It's documented by ThoughtWorks, which makes it, officially a pattern. And it was called, Biffy. And I have to tell a story because I need some humor in my talk. So Biffy was great for the Germans because there's these individually wrapped sausages in Germany that you can get everywhere called Biffy. And I think in Australia it would be beefo, but Biffy in German. And the Brazilians loved it because Brazilians love steak, and Biffy means steak in Brazilian. And Brazilians seem to love steak more than the average world citizen. But the Dutch people had a problem with it because, are there any Dutch speakers amongst us? Yes. Could you tell me what this means in Dutch?
It means yeah.
Oh, okay. Like a takeaway or?
No.
I wasn't expecting you to actually answer that. So the Dutch people couldn't take it very seriously. They're like, I'm not going to send emails to beefy@soundcloud.com. Like, can you please change this name? And we had like the most interesting email thread in all of SoundCloud history. Was talking about like the name, like what's wrong with this name, and whether there were some people who were defiantly like, no, like we should not, be afraid of. We're all adults here, and actually, it's a wonderful act that should not be considered. Yeah, it was intense. It should be framed. It was great. But anyway, we decided, okay, like let's keep it safe for kids, and we switched back to we called it BFF and the milk and the cookies. Anyway, I thought it was like the worst logo ever. Worst is sausage in German. It's my dad joke. So the shared concerns that this framework had, and all of like the microservices like needing to share code to deal with microservice land, we had to deal with authentication and user sessions, URL parsing, feature flags for deployments, service discovery, metrics, alerting, logging, errors, health checks, circuit breakers. And some of the frameworks that we used had some of the stuff baked in, some of the stuff we had to build. And that's why we converged on the JVM kit. We tried to start building this out in Node.js and trying to keep up, but you need a separate team in the end, or it's a lot of work to do that. So in the end, all this functionality we're adding on top of the Finagle stack for the presentation APIs, we're able to use generally, and people just realized that it was a lot less work to get in on what a lot of the other teams were using and what was being well maintained. Going a level down, so the microservices, were generally Scala HTTP services with JSON, and they had their own backend. So originally the Rails server had, a MySQL database with just everything in it. We had like heaps of slaves and one master, and huge tables, and really like tables with so many columns. Like the user model was at least 50 columns wide. And the process of each microservice was discovering, which tables can we pull out, which columns can we pull out to have a smaller database to optimize reads and writes. But we let the teams choose which backend was more appropriate. So we still have a lot of MySQL, and I think for databases standardized on that. And just because we have it, we have all the knowledge. We've written, for example, the large Hadron migrator to migrate in place huge MySQL tables. And we have a lot of small Cassandra instances for a key value pair type, or even some time series based microservices. Then we have a lot of memcached. We have RabbitMQ for async messaging between the services. So the services communicate with each other either via HTTP or by consuming messages or listening for messages on queues whenever interesting user events happen. And then the events that are emitted as messages are also stored in logs on Hadoop, so that if we have like big data jobs, they can use Hadoop infrastructure for that. One of the big challenges, I think the only way it was possible for us to really go fast with microservices and we were discovering how to do it as we were going along. We didn't really have any clear blueprints, but one thing that really made it possible was we had a deployment infrastructure. So at the time, Heroku was really big, and we had come from the Rails world, so we had built our own Heroku-like deployment infrastructure, which we called Bazooka. And that was fantastic because you could just like Heroku, you could do git push Bazooka, and then Bazooka scale. It wouldn't be automatic scaling, but you could clearly just change the number of instances you had, and just make deployments so easy. And it had a number of commands to show visibility of what your processes were doing. And of course, the Docker and all of that, Kubernetes has come along since then. And we've had some issues because we had modeled Bazooka off Heroku. A lot of Heroku was Rails processes or lightweight processes, and we had moved to the JVM, and the JVM is kind of itself a server. So there was a bit of an impedance mismatch there. So Bazooka was great. It really helped at the time when there wasn't some products that we have available now, but we're moving away from that because there's a lot of process scheduling problems, and to have to maintain that in-house is quite hard. So Kubernetes is looking really appealing there. Another fantastic thing for monitoring all of your services is Prometheus. Has anybody not heard of Prometheus? Okay, great. Check it out, prometheus.io. It was built by a couple of Soundclouders originally, and then a big community of open source got behind it. I'll show you a screenshot. It's just, we had StatsD and Graphite, and StatsD didn't scale. It was a central bottleneck and failed pretty quickly for us, and we thought, how can we scale it? And then we moved to this model of distributed metrics collection. So Prometheus allows each little service to have an in-memory counters for the metrics, and then there's a Prometheus server that's going to scrape at intervals each service for their metrics, aggregate them, and then you can have another dashboard service, kind of like Graphite, reading from these collectors. And it's the developers have written their own database for this specific type of data, and it's very performant, it's very flexible, and it's got a really nice JavaScript graphing UI. So this is an example of a service where a dashboard, Prometheus dashboard, and each microservice, we have a template of each what graph you can expect to see. So this is just the HTTP status, number of 500s, number of external versus internal 500s, because we're doing a lot of calls to internal microservices. So you can easily see a breakdown of, okay, if we've got 500s, which internal services are 500 in, and also latency times, lots of other good stuff, JVM garbage collection times, memory and CPU. So, yeah, but microservices is not free lunch. So I was at the, I'm kind of running out of time, sorry, I didn't realize I had so much to talk about. If you want to come to Berlin, come for the Chaos Communication Camp. It's like hacker festival. It's out of this world. It's every 4 years, so it just happened last summer. But there's all of the hackers unite and create crazy stuff, funny jokes, free Biffy. And what's really annoying is that I actually packed Biffy. I packed 10 rolls of Biffy to give out today, and I forgot to bring them. So I'm going to have to like offload them to my family or something. But yeah, it's not a free lunch, and I think there's a QCon talk by Phil Calzado, who was involved in a lot of the architecture. You probably all know that if you're making the transition or have been operating in microservices a lot yourself. I'll just quickly run through the benefits we found. The team productivity, not having to have bottlenecks of coordinating with like lots of other builds on the same code base, and with that you also get failure isolation. You don't bring down other services with your bugs, and it makes deployments easier, smaller. You can experiment more. So we have I'm experimenting with function injection in Scala instead of object or class injection, and I can just do that in my little small thing, and I can say, hey, I'm trying this out here, and I can see how it is without making it a big company-wide thing or creating too many lava layers. I can rewrite later if it turns out to be not useful. This is just an indicator of what I think is developer productivity. This blue graph, this commits over time on our public API controllers and representation classes versus on these the API mobile aggregated API. So that was that API specifically just for the mobile clients. And we've had our public API since 2008, so you can see it's fairly constant, but the API mobile developers can just deploy frequently. They can change stuff so frequently without worrying about bringing others down or having to fit in with other people's needs. We also, a huge win performance-wise was for our mobile clients, that they could, because we've broken services up, and they could just get exactly the data they need. They wouldn't have to pull in everything in the user model every time they're asking for one slice of the picture. And aggregating all these requests together really cut down. So before we had to do maybe 5 parallel requests, and then, not parallel, sorry, just 5 requests, some sequential, some parallel, and afterwards it's just kind of one big one to optimize for latency. And one maybe not so obvious benefit of the microservices for us is the team has laser focus. So we just started a new sign-in team that I'm on, myself and the other developers, let's create this team, we need to create this team, we need to look at sign-in and sign-up logic, which was in our Rails controllers that nobody understood anymore. And we started this team, and as soon as you've got a small team dedicated to looking really more, we were able to find some efficiencies that we could implement to really boost numbers. We could really tune into the KPIs and the metrics of that domain area, so I can tell you exactly. I'm not going to tell you because it's being recorded, and I wouldn't tell you anyway. I could tell you how many Facebook, Google+, email. I know these numbers. I see them daily. There's a lot of challenges. I might leave that for Q&A because this is already 30 minutes.
That's okay.
Okay. So, questions? I think your hand went up just before. Yeah.
So when you've got these mobile clients talking to the BFF,
yeah.
actually found
Now, yeah.
deal with failure, does that BFF become a potential point of failure? How do you deal with, say, some services being up another?
Yeah. So I think there's a number of questions in there, but one was you've got these BFF presentation APIs that are fanning out to services. How do they deal with failure of individual the backend services? I can answer. So that one is you try to gracefully degrade. So you try to handle, for example, the like service. If the like service goes down, just empty likes representation for now. Does it become a bottleneck? Was another question. In terms of bringing down the whole client. Yes. That is a problem. So it's still better than bringing down all clients, the web client included. What we're considering is, perhaps instead of these big presentation APIs, perhaps we should have, again, splitting them up domain-based. It's not so clear. I mean, things are working okay. We're just trying not to bring it down too much with feature, like we're going into the other measures of ensuring that we're not bringing it down. But yeah, it's not a clear-cut thing, it's definitely a trade-off.
So my question was sort of like that last thing you spoke about, where those clients were monolithic.
Sorry?
Clients are monolithic.
The clients are monolithic, yes.
So as far as the friction between the front end and the microservice team, is that improved now when we've got that microservice team looking after the live service with?
For sure.
You've got the guys consuming that service in the front end. Yeah, especially I suppose mobile clients are a bit hard to get someone for deployment anyway. But front end, that's probably easily broken down method to it.
Yeah.
I think. If you have it broken down at the client side or just at the back end?
Yeah, so it depends how the clients have been architected. I mean, they are generally architected to be modular, so I know for the I can't speak for the web app, but for the Android app, where we've got like a feature-based package model, for example, so you can really clearly see interfaces between dependencies. And the question was,
the teams building.
yeah, is there less friction in the teams building the clients now with the specific microservice team? So the main improvement over friction is that if you have just one team looking after, say, the comments service, before it used to be the public API team, and they would look after the whole domain. So context switching, having to be the master of all domain areas. Now the comments people, you would just go to them and say, we need this extra field, or we need this change, we need threaded comments. And they're like, they have the context sucked up, like they deal with it daily, so they're much more proficient at it. They've got less requests coming because not everybody's dealing with comments. So that was already a win. Yes?
How has it worked as you've broken up the services organizations, like from a team base? So kind of two questions. Are the teams fluid? Do you move developers around? And then how do you comprise the teams? Is it mostly development, or do you embed like business owners into those teams? How's it switched?
Yeah, so definitely business owners like in the feature teams, and we may not have a one-to-one business owner to team. They might be aggregated. For example, I'm in the sign-in team and under the growth umbrella. So there could be the growth PMs across a couple of projects. In terms of developers moving around, that could happen better, I think, in my opinion. Like, it's still like what we're struggling with is islands. Like we don't have that many developers, and we have a lot of feature teams, and you can get really small teams then. So we used to have bigger teams of 4 to 6, and now we have sometimes teams of 2, and so that bus factor is very dangerous. And so we're currently considering how can we do more sharing. Also with PagerDuty, you can't have like one developer have to be on call all the time. So I think again in constraining to the stack and to try to encourage people to move around and share. Yes?
How do you manage or you do reusability, especially that you got those multiple teams?
How do we do usability in the feature teams?
The reusability for things to be reusable across the teams.
Like on the code level, or on the, like you're talking about usability in the UI?
No. For things to be reusable.
For things to be reusable, like libraries or so that touches, this is great. Like I didn't have to even create slides for the challenge part. Like, this is bringing them all up. Reusability is really hard. Duplication, there's a lot of duplication. You have to have really like clear communication channels of, hey, we have this problem, what other team has had it before. We have these, as I said, these dedicated core teams, core libs, core services, and they're specializing in, there's some systems that are like core, like that every team is going to have to touch, like authentication. So there's an authenticator service who might be the custodians of, dealing with the user session and like a library around that. So we have this JVM kit library, which has all of these common reusable building blocks, like a user session that deals with a bit with caching or, but that's fairly obvious, like when it's an infrastructure or like you can imagine that another service needs it. What's a bit trickier is the business logic. For example, we had to, if you have to upload a track on SoundCloud, you have to do some validation checks. Where do you put those validation checks? Do you put them in the presentation API? We had like some duplication happening across in the presentation APIs. What we found is like try to push that down, try to make like the owner microservice of the upload domain, deal with the checks and then propagate them on. Yes?
How do you tackle the interfaces between microservices? Is it a sort of very RPC kind of feel? Do you use some kind of API definition language?
The question was how do we deal with the interfaces between? Originally, it was just on the GitHub README, like here's the API documentation, and that was often just a link to the controllers package. But now we're investigating Thrift. We're investigating Thrift because another problem with the code reusability is that all this client code, this HTTP JSON stuff, like it sounds like it shouldn't be much, but in reality it is. You still have to handle failures, you still have to, like parse things, and often you're parsing similar things, and if everybody has to do an upload, everybody has to write the HTTP JSON code for the upload. So we're experimenting with Thrift. We've got a couple of microservices using that now. Yes?
So in one of the slides that you said about feature toggle, is it a microservice itself, and how other microservices actually interact with the feature toggle?
Yeah, the question is feature toggles the microservice itself, or how is it implemented?
Yeah, and then how the other microservice actually interact with that feature toggle.
How
because from what I understand, the feature toggle is actually live inside of each of the microservice when you want to turn on and off.
Yeah.
But then if the feature toggle we have like as a microservice, so how the other service actually interact with that one?
Yeah, that's like a good blog post in itself. So each service, we have in this JVM kit shared library, we have a rollout object, and that like magically uses Zookeeper to like do the feature flags for you and know like, based on user ID, you're going to be in the feature or not. And that's very like, microservice specific. In terms of orchestrating, like if you have a feature crosses multiple, how do you make sure the user is in the same one? We actually use A/B testing for that. So feature flags we try to keep just to the service or the component, and it's more for just rolling out a code change. But for bigger experiments, we have an A/B testing framework, and that itself is a microservice. So we have, a front end for creating experiments and like an assignment service where you can ask it, what experiment is this user in?
Do you work in German?
Do I work in German? Leider nein. Yeah, Berlin is the wrong place to go to learn German in Germany.
I was just curious, there's so many English speakers, right?
Yeah, we
I
have.
just wonder what the common language is.
Yeah, we have 36 nationalities. The common language should be Lojban, but it's not, it's English. Lojban is like one of these artificial languages. When I was in the payments team, I was surrounded by Germans who were happy to speak German, and I really loved being in the payments team for that reason. It's great. I just wanted to quickly show you, I had like another slide. We're using ThoughtWorks Go. One of the biggest challenges, biggest like outage reason was deployments. So you go from like deploying one big thing to deploying 200 things, and each thing can fail and like have knock-on effects. And we're using this Bazooka service, which was fantastic, but we didn't have really tight, strict, failure-free deployments. So deployments were costing us a lot when we looked at our post-mortem reports. So we've moved to continuous delivery pipelines, so it's all automated and just a continuous click. And we've moved to Go, ThoughtWorks Go recently, just to plug ThoughtWorks. So I used to work for them. And another big challenge we have is just generally the JVM, like going from a Rails shop to a JVM shop, getting that knowledge about JVM tuning. We now have a JVM expert from Twitter who helps us with memory leaks and understanding that generally, but that was like another big source for us learnings. Any other questions, or are we
Maybe one more?
One more, okay. Yes.
Was there a situation where a microservice was updated and took down other APIs?
Yes.
And how often does that happen? Because the business structures are different. The actual entire everything except for the microservices is different. How do you automate that?
The question was like, is there some microservices take others down? The ones that take them down are the core ones, like authenticator. That's pretty hard to deal with. Like we can go into like some read-only mode for a while. Like the clients everything has to have graceful degradation kind of built in. And generally, yeah, like the like service shouldn't bring down follows.
About the upload service.
The upload service, that's still pretty contained. Like you won't be able to upload, but you'll be able to interact with the rest of the site. Yeah. All right.
Okay.